Over our shoulders and get ready to start digging. Welcome to
Part 3, Roots.
In this section, we're going to talk about squaring numbers as well as finding square roots and other higher roots. But before we get there, we've got to take a little detour and talk about absolute values. Let's get started with that.
Section A, absolute value.
One way to understand the absolute value is to imagine a number line. If you have one in front of you, it's even better. When we've got a number line, we can figure out how many units away from zero our number is, and this is what the absolute value is all about. Check this out.
If we're asked to find the absolute value of 5, we see here that it would be 5 units from 0 on a number line. That means the absolute value of 5 is 5. We see it written like this. Those straight lines on each side of the 5 mean absolute value. Likewise, the absolute value of -5 would also be 5, because -5 is also 5 units away from 0.
There's no such thing as a negative absolute value. It is always positive, or 0. We're simply counting the number of units that a particular number is away from 0. So the absolute value of 0 is 0, and the absolute value of any non-zero number is always positive.
So the absolute value of -3 is 3. The absolute value of 804,329 is 804,329. And remember, the absolute value of 0 is 0.
Woohoo! Now that we've got absolute values pegged down, let's go for squares.
Section B, squares and square roots.
In this section, we're going to take a look at the expansive world of roots. There are many different types of roots, but we're going to start with square ones and work our way up.
Back at the beginning of the program, we talked about the square of a number. Remember when we see something like 9 squared or 7 squared, that means we multiply the base 2 times. So 9 squared equals 9 times 9, or 81, and 7 squared equals 7 times 7, or 49. Well, finding the square root is just like doing the opposite of finding the square. Check it out.
See how 9 squared equals 81? Well, that means the square root of 81 is 9. Same thing with 7. 7 squared equals 49, so the square root of 49 equals 7. The square root of a number is simply the original number we multiplied 2 times. We use this symbol here to mean square root. It's called the radical.
This just in, the radical means we take the square root of a number. The number underneath the radical is called the radicand, and the whole kit and caboodle is called the radical expression. Let's go now to Carrie Curtis live on MathCam for more. Carrie?
That's right, Ralph. And we've been out here all day asking people that one key question. What do you do with the radical once you found the square root? Here's what they had to say.
When you find a square root, you just chuck it.
You heard it here first, folks. When you find the square root, you just chuck the radical. I'm Ralph Newsman. Good night.
So if we saw the number 25 under a radical, that means we want the square root of 25. Well, what number multiplied 2 times equals 25? The answer is 5, so 5 is the square root of 25. We express this by writing a plain 5 and getting rid of the radical.
Now in the math community, or in one of your books, you might see a formula with some letters in it to explain the square root. Let's see what it looks like so it won't catch you off guard.
If you come across this, the number c is the square root of a if c squared equals a. Don't worry, this is just the letter version of what we've been doing with numbers. See how it works if we substitute the number 36 for a? Now, what number multiplied 2 times equals 36? We figure out that c equals 6, because we know that 6 times 6 equals 36.
Okay, now that we've got that down, in this jungle of roots, there's something else we've got to look out for. We know the square root of 36 is 6 because 6 times 6 equals 36. But -6 times -6 also equals 36 because 2 negatives multiplied together equal a positive. This means that -6 is also a square root of 36. Let's look at this in more detail.
So how do I know when to give the negative answer or the positive answer?
Well, there's just a little something you gotta watch out for. You gotta pay attention to the way things are written.
When we see a radical sign, just a plain old granola natural no frills radical sign, it means we're looking for the positive square root of that number. See here, the square root of 9 is 3. Easy, right?
Now, if we want the negative root of a number, we'll see it written like this, with the negative sign in front of the radical. Not under the radical, but in front of it. This means we want the negative square root of 9, which equals -3.
So when we've got that negative sign in front of our radical, that's when we want the negative root.
Now, so far, all the numbers we've been considering have not only been squares, but also perfect squares. A perfect square is a number that has an integer square root. For example, some of the perfect squares are 1, 4, 9, 16, 25, 36, 49, 64, 81, and 100. They're perfect squares because their roots are integers.
The square root of 1 is 1. The square root of 4 is 2. The square root of 9 is 3. The negative square root of 16 is -4.
Now, these are all integers or whole numbers, which when multiplied twice equal other whole numbers. They're not decimals or fractions. This is why they're considered perfect squares.
But in this imperfect world, it's also possible to have squares that aren't perfect.
Take the square root of 18, for example. 18 is not a perfect square because no integer times itself equals 18. So let's try something a little tricky here. We're going to break this thing down to try and find some factors of 18 that might actually be perfect squares. Our first step in this process is to think of some factors of 18.
How about 6 and 3?
Well, yes, these are factors, but neither of them are perfect squares, so that doesn't really help us. But look at the factors 9 times 2. We know that 9 is a perfect square that has a square root of 3, so this is good stuff. These are the factors we want to use. Now, instead of 18 under the radical, we can make it 9 times 2. Then we can take the square root of 9. Remember, we express this by taking the 3 out from under the radical sign, giving us something that looks like this. 3 times the square root of 2. Why can we do that? Well, since 9 is a perfect square, we can take the square root of that factor, which is 3, and bring it outside the radical. This is how we end up with 3 times the square root of 2.
Now, technically, we can find the square root of 2 by writing it as an ugly-looking decimal. But for right now, we're going to leave that 2 under the radical sign because it's not a perfect square. So our final answer would be 3 times the square root of 2.
Now, just like we wouldn't win a gold medal in the Great Pancake Bake-Off if we never practiced making pancakes, we've got to practice our skills with non-perfect squares to make sure we've got them down. So let's do a few more.
How about 120? That's a nice, hearty number. If we've got the square root of 120, we can factor it down to the square root of 12 times 10. Well, 12 can be broken down to 4 times 3, and 10 can be factored into 5 times 2. So we've got the square root of 4 times 3 times 5 times 2.
Since 4 is a perfect square, it can be taken out from under the radical as a 2, giving us 2 times the square root of 3 times 5 times 2. Notice that none of the numbers left under the radical are perfect squares, so we can multiply them back together. When we do this, we've got 2 times the square root of 30. We keep our answer at 2 times the square root of 30 because 30 is not a perfect square and doesn't have any factors that are perfect squares.
Okay, you wake up to find the square root of 72 hanging like a mobile from your ceiling. Immediately, you stare it down because you know how to deal with it. You say,
72. I know what to do this time. Advantage. Mine.
The square root of 72 can be broken down to the square root of 12 times 6, which can be factored to the square root of 3 times 4 times 3 times 2. Now we can remove a 2 from under the radical because 2 is the square root of 4. Yeah! But, aha! This time I noticed that we're left with 2 times the square root of 3 times 3 times 2. See how 3 times 3 equals 9? That means 9 is a perfect square. So we take the square root of 9, which is 3, by placing that 3 outside the radical. Now we've got 2 times 3 times the square root of 2. Well, we can multiply our integers 2 times 3 to get 6, and we end up with an answer of 6 times the square root of 2. Yeah!
Nice work. Remember, squares and square roots are a very important part of algebra. So if you think you missed something or just aren't sure about how they work, now might be a good time to skip back and check it out again. You'll need to use the concepts in order to get the next section. But if you're ready, let's move on and tackle higher roots.
Section C, higher roots.
Most of what we've talked about so far has revolved around the square roots, but they're not the only roots of this earth. There are such things as cube roots, fourth roots, fifth roots, caret roots, family roots, tree roots. When we talk about any number roots greater than square roots, we stick them all under the umbrella of higher roots.
Let's start with the first higher root, the cube root. Remember that when we have a number cubed, for example 4 cubed, it means 4 times 4 times 4. When we cube a number, we multiply that number 3 times.
A cube root, then, is just like a square root, except this time we're looking for a number multiplied 3 times to get another whole number. See that little 3? We say that 3 is in the arm of the radical, and it signals to us that we're looking for the cube root. An example is the cube root of 729, which equals 9, because 9 times 9 times 9 equals 729.
Take a look at the cube root of 8. Now, what number multiplied 3 times equals 8? The answer is 2, because 2 times 2 times 2 equals 8.
Similarly, the cube root of 27 equals 3, because 3 times 3 times 3 equals 27.
Now, cube roots are different from square roots because when you've got a cube root, you're dealing with 3 numbers, and when you have a square root, you're dealing with 2. This can affect your answer if you've got negative numbers, so make room in your mental duffel bag for the following information.
Whenever we have a cube root or some other odd root, it's possible for us to end up with a negative number under the radical. This is because whenever we multiply an odd number of negative integers together, our answer is negative. Take a look at this.
If we have negative 2 times negative 2 times negative 2, we get negative 8. So, if we're asked to find the cube root of negative 8, we know that the answer is negative 2.
Now, notice how this is different than when we work with even roots. Whenever we multiply an even number of negative integers together, our answer will be positive.
If we multiply negative 2 times negative 2, we get positive 4. Because a negative times a negative always equals a positive. So in our travels, if we come across a negative number under the radical and we're looking for an even root, like the square root of negative 4, we're going to say that it's undefined.
It's undefined.
It may sound a little confusing, but it's not that bad once you do a couple of them. So let's go through it one more time.
If we're looking for an odd root of a negative number, like the cube root of negative 27, we can say that the answer is negative 3. This is because negative 3 times negative 3 times negative 3 equals negative 27. Now, if we're given a negative number and asked to find an even root, like the square root of negative 16, we're going to say that it's undefined. The reason we say it's undefined is because we can't find one real number multiplied 2 times to equal negative 16.
Now there's one more teeny tiny piece to this whole positive-negative bit. Remember earlier in the section we talked about the negative square root of a number? Well, this is altogether different than the square root of a negative number. The good thing is that it's easy to tell which one we're looking for by where the negative sign is. Take a look.
Notice how the negative sign in this case is underneath the radical sign. This means we're looking for the square root of negative 16, which we say is undefined. But this is different than when we have a negative sign in front of our radical. Remember that this means we're looking for the negative of the square root of a number, which we can do for any number. So here, the negative square root of 16 is negative 4.
Okay, let's get away from negatives for a while and go forward to one more higher root. So far, we've looked in depth at square roots, then cube roots. Now let's check out an example of the fourth root.
Raising a number to the fourth means multiplying that number 4 times. So saying the fourth root of something means finding the number that when multiplied 4 times gives us a particular number. For example, the fourth root of 16 equals 2, because 2 times 2 times 2 times 2 equals 16. Likewise, the fourth root of 81 equals 3, because 3 times 3 times 3 times 3 equals 81.
Following that pattern, we can find the 27th root of a number, which would be the number that when multiplied a total of 27 times gives us our original number.
Of course, the chance anyone will ask you to find the 27th root of a number is about as likely as someone asking you to build a house out of bubblegum and tinfoil. But hey, it could happen.
Okay, it's that time again, folks. We've come to the end of the section. Please make sure that your seat is in the full upright position, with your safety belt fastened, your mind open, and your infrared review goggles on.
Remember, the absolute value of a number is always the positive value of that number. Or if we've got 0, the absolute value is always 0. To find the square root of a number, look for two identical factors. Since the square of 12 is 144, then the square root of 144 is 12. Remember that after we get the square root of a number, or any root, we take it out from under the radical sign.
And if we see a bigger number in the arm of the radical sign, then we're looking for a higher root. So if we see a 6 in the arm of a radical, we're looking for a number when multiplied 6 times gives us the number under the radical. If we catch an even root with a negative number under the radical sign, we say it's undefined. But a negative number with an odd root is okay. Now, this is altogether different than taking the negative root of a number, which we can always do when we see the negative in front of the radical.